The lesson for today is states of matter, and the topic which we are going to cover is diffusion. The learning objectives for today to be able to explain diffusion in liquids and gases. The food. You can smell the food, right, children? Whenever mommy is making any food in the kitchen, you can guess sitting in your room that what she is preparing in the kitchen. And you can say, wow, today this dish, mom is making this dish, mom is making that dish, right? How does this happen? How does the smell reaches to our nose? That's what we are going to study. How does the particles of the food reaches to our nose? How we guess the food? How does the particles of the perfume reaches to our nose and we say, oh, your perfume is very good. That's what we are going to study today. Diffusion. What is diffusion? How it happens? How do the particles move from one place to another place? Let's see. So what is diffusion? Diffusion is the movement of the particles from its higher concentration to its lower concentration. Children, concentration means amount. This is for your understanding. I have put the word amount. But make sure you write in exam the word concentration, from its higher concentration to its lower concentration. Let's take an example here. Suppose this is the food particle inside the kitchen, okay? Or inside the container where the food is made. So inside the container, the food particles is more or less? Yes, it is more inside the food container, right? Okay, as soon as you open the container, as soon as you open the utensils, where the food is made, what will happen? The particles from inside the food will move out slowly and slowly. And what are these particles? Are they solids, liquids or gases? They are gas particles. So the particles, they move out in the form of gas and they reach from one room to another room and then finally it reaches to us. And then we will say the food is ready. So the particles, they are moving from their higher concentration. So the amount of particle is more inside the food. The concentration of the particle is more inside the food. So from its higher concentration, from its more concentration to its less concentration, which is in outside room or the other rooms of your house, the particles are less the food particles are less, right? So it is moving. It means the food particles, they are moving from its higher concentration to its lower concentration. The word it means food particles. Let's see this in the form of a video. What happens here? The gas particles inside this box, inside this place, the gas particles, they are yellow in color and they are more in number. They are more in amount. They are higher in concentration. What happens? As soon as I make a small opening here, what happens? The particles, they will move out from its higher concentration. This is the higher concentration. And the particles are moving from its higher concentration to its lower concentration. Means the particles outside this box, they are less in concentration. They are less in amount. So particles, they will move from its higher concentration to its lower concentration. One more example here, bromine gas. So what I take two measuring cylinders and in one of the measuring cylinder, which is kept down here, I fill it with an orange color gas, the bromine gas. What I do, I take another measuring cylinder and I put it inverted over the lower measuring cylinder. Between both the measuring cylinders, I will put a cardboard. Okay, so I'm not allowing this bromine gas to reach here, right? So this is empty measuring cylinder and this is filled with bromine gas. Now what will happen? If I remove this cardboard out, what will happen? The gas from the lower measuring cylinder will go into the upper measuring cylinder. So gas particles, they will move from its higher concentration to its lower concentration, and after some time both the measuring cylinders will be entirely filled up with the same amount of bromine gas particles. So what is diffusion? Diffusion is the movement of one type of particle into another. For example, the smell of food or perfume reaches across the room. Diffusion occurs both in liquids and in gases, but hardly in solids. It happens more quickly for gases than in liquids. Diffusion happens more quickly at warm temperature. Warm temperature means at a higher temperature. At hot temperature than at cold temperature. This is a quick animation showing you the diffusion of the particles from its higher concentration to its lower concentration. What do you see here, children? The particles, they are getting scattered here and there from its higher concentration to its lower concentration. So particles of bromine, they are moving from its higher concentration to its lower concentration. I will use that in one word, that particles of bromine are diffusing. So diffusing means, again, particles of bromine, they are moving from its higher concentration to its lower concentration. So finally, now you understand how food smell reaches to us from the kitchen. So food particles travel from the food container where it is made. It is reaching to our nose through the air by the process of diffusion. Any smell which we get, it's coming because of the process of diffusion. Let me ask you one question here. You can see two cars here, right? Can you tell me, if I make a race for these two cars, which car will win the race? Do you think it will be red car or the yellow car? Yes, the yellow car will win the race. Why? The lighter, right? The yellow car is lighter than the red car. The red car is heavier. So the lighter, the faster. Based on this concept is our next experiment, that is called as, again, diffusion of two gases according to their masses. Let us see how diffusion of gases happens according to their masses. So I will be taking a transparent glass tube which is open from both the ends. Left side open and also right side it is open. What I am going to do is I will take two cotton plugs. One of the cotton plug I will dip in ammonia. Chemical formula of ammonia is NH3. I will dip the cotton plug in ammonia and I will cover the left open end with this ammonia dipped cotton plug. On the other side, I will take other cotton plug. I will dip that cotton plug in hydrochloric acid, formula is HCl, and I will cover the right hand side open end with this cotton plug dipped in hydrochloric acid. Now students, keep in mind the masses of ammonia, which is 17 grams, and mass of hydrochloric acid, which is 36.5 grams. Can you guess which is heavy and which is lighter? Ammonia is 17 grams, hydrochloric acid is 36.5 grams. Which is lighter, which is heavier? Of course, ammonia is lighter. Hydrochloric acid is heavier. And both of them, they are in gas state. So particles will move from the cotton inside the tube. So hydrochloric acid from the cotton, it will move in the form of gas to inside the tube. Ammonia gas particles also, they will move from the cotton to inside the tube. Now, keep in mind children, the masses of ammonia and hydrochloric acid. Ammonia is lighter. Hydrochloric acid is heavier. Who will run fast? Yes, very good. Ammonia will run faster. He will run at a faster speed as compared to hydrochloric acid. So when ammonia will run at a faster speed, being lighter, it will reach more closely or more close to hydrochloric acid. So you can see after some time, ammonia reaches towards hydrochloric acid. Whereas at the same time, hydrochloric acid reached only up till this distance because it is heavy. Now what happens? Ammonia and hydrochloric acid, they both will react together. A chemical reaction will happen, react together, and they will form a white powder, which is called as ammonium chloride. So ammonia was gas, NH3 was gas, right? HCl was gas, and both are colorless gases. They both traveled. Ammonia traveled from left end, hydrochloric acid traveled from right end, and both of them, they met somewhere inside the tube. They reacted together and they formed ammonium chloride. So you have to investigate, where will ammonium chloride be formed? Will it be formed right in the middle of the tube? Will it be formed towards ammonia side, or will it be formed towards hydrochloric acid side? It will be formed towards hydrochloric acid side because ammonia is lighter, so it ran faster. The particles move faster, whereas hydrochloric acid has more mass. It's heavier, so it will move slowly towards ammonia side. So by the time ammonia reaches here, at this point, hydrochloric acid has reached only till this point. Both of them, they will meet and form ammonium chloride, which is the white powder near the HCl or hydrochloric end. Now you will see how this experiment is conducted inside the laboratory. Can you see the formation of ammonium chloride, children? Yes, this is the white powder which is called as ammonium chloride, formed due to the reaction of NH3 ammonia and HCl hydrochloric acid. Can you investigate and tell where is ammonia in this tube and at which end is hydrochloric acid? Investigate. Take your time. Very good. So at this end, ammonia is kept. Okay. This end is ammonia. So he traveled faster. The particles of ammonia, they traveled faster due to light weight, due to less weight. Whereas hydrochloric acid is kept on this end due to heavy mass, heavy weight or mass. So it is kept on this left side. It just travel up till hydrochloric acid particles, they just travel up till here. At the same time, ammonia particles, they travel to up to this distance. So finally, the white colored ammonium chloride powder is formed towards the hydrochloric acid side. Similarly, diffusion also happens in liquids. Let's take an example of diffusion in water. Take a glass of water. Make sure the glass is transparent. And in that water, put a pinch of food color. What will you observe? You will see that the color moves out from its higher concentration to its lower concentration, thereby slowly diffusing in the entire liquid and changes the color of the full water. So what are the factors which is responsible for the rate of diffusion, for the speed of diffusion? So one of the factors responsible to make the diffusion slower or faster is temperature. Temperature means amount of heat. Heat means what? Heat means it's a type of energy. So girls, if I take one, like a small room, and in that small room I take 100 girls and I say all of the 100 girls will stay in this small room, and I switch off the AC, what will happen? The temperature of the room will go up, right? The temperature of the room will become hot. The more hotter, what will happen? Will you be comfortable in that room? Will you stay in that room? And I close all the doors and windows also. What will happen? You will feel hot. You will try to run away from each other. You will try to push each other. So, as soon as I open the doors of the classroom, what will happen? You all will try to move out of the class, right? In the same way, particles, when they gain heat energy, they try to run away from each other. Suppose I keep you all in a closed classroom, 100 girls in the same classroom, and it's a winter season. We do not want AC. It's a cold temperature. What will happen? Will you stay there or will you try to run away from each other? Will you try to push each other at cold temperature? You will not mind. You will stay there. You will say, no problem. We are comfortable here because it's already cold outside. Yes, in the same way, particles, when they are cold or at a lower temperature, they move very slowly. They don't try to move away from each other. They are stable at their own place. So as the temperature goes higher, as the energy increases, what will happen? The particles, they will try to run away from each other because energized particles, they get energized. So hot means more temperature. When the particles, they are more hot, they have more temperature, they have more energy. That means they will try to move away from each other. They have more energy. So in hot water, diffusion will be faster. You will take a pinch of sugar and put it in hot water. It will dissolve very fast because sugar particles, they will gain energy from the hot water and try to move here and there faster, and the entire water will become sweet in less time. Whereas in normal water, it will take little more time than the hot water. Whereas in cold water, it will take longer time for the sugar to dissolve because it is cold. Energy is less. Particles will not get energy. They will not move faster.
Water vapour spreads out into the atmosphere. It's carried by the wind, but it can also spread out of its own accord by a process known as diffusion. Invisible gases behave in the same way. The particles in a gas move randomly in all directions. This helps explain why a gas diffuses from one place to another. You can see diffusion happening on a small scale in the lab using bromine, an orange-coloured gas. Place a jar of air on top of the bromine and it slowly starts to spread. It's moving up the tube against gravity. Over time, the two gases mix. After half an hour, both containers have a uniform colour. It takes time because the air and the bromine molecules are colliding with themselves and each other. So what would happen if there was no air for the bromine to bump into? All the air has been removed from this apparatus, apart from the flask containing bromine, which is isolated by a tap. Open the tap and it spreads immediately. Watch again. In a vacuum, there's no air to collide with. The bromine diffuses much faster. See how slow the diffusion is when the flask is now full of air. It takes several minutes to get just this far. This simple setup can be used to compare the rate at which different gases diffuse into air. Nitrogen dioxide gas on the left is similar in colour to bromine on the right, but bromine molecules are much heavier. The lighter nitrogen dioxide diffuses more quickly. We can also compare the diffusion rates of other gases. Ammonia and hydrogen chloride gas are colourless, but when they meet, a white cloud of ammonium chloride forms. A piece of cotton wool soaked in concentrated ammonia solution provides ammonia gas. Concentrated hydrochloric acid provides hydrogen chloride gas. Place the two pieces of cotton wool at opposite ends of a tube and the gases spread out. You can compare the speed at which they approach each other by looking out for a cloud of ammonium chloride. After less than a minute, a white ring begins to form, marking where the gases meet. The white solid is closer to the hydrogen chloride end of the tube, on the right. So which gas has travelled faster? Another way of monitoring the progress of the gases is to run a piece of damp indicator paper along the tube. Hydrogen chloride gas turns it red, ammonia turns it blue. Why does ammonia travel faster?
So students, here is an example of how the question of diffusion can come in the exam, how it can be asked in an exam. This is the sample question from your IGCSE exams. They will display a diagram of the experiment of diffusion conducted in the lab with the help of ammonia gas and hydrochloric acid. Both the gases are in vapor state or in gas state. Remember, the masses of the gases will never change. The mass of ammonia is always 17. The mass of hydrochloric acid is always 36.5 grams. So what happens? Something will be formed. Reaction will happen between ammonia and hydrochloric acid, and the product ammonium chloride will be formed. How it is formed? Because the particles of ammonia, they diffuse, they move from higher concentration to lower concentration, and the particles of hydrochloric acid, they diffuse from its higher concentration to its lower concentration, and both of them, they make the final product. They react together to make the final product called as ammonium chloride. So what has happened? Diffusion has happened, right? So what is the process? What do you think is the correct answer for this? Is the process condensation? Is it crystallization, diffusion, or evaporation? It is diffusion. Now you have to tell the movement of the particles according to the diagram given above. So the movement of the particles, remember children, it depends upon the mass. The more the mass, the movement of the particle or the diffusion of the particle will be slower. The lighter the mass, the lesser the mass, the diffusion of the particles will happen faster. So you have to write the last answer accordingly, depending upon the mass of the particle, how and which particle will move in which direction. I hope you understand the entire lesson. If there is any doubt, any question you have, you can please ask me through WhatsApp, through a call also. Okay. See you then. Bye bye. Stay safe.